There is a specific number in tonight's Hawaiian Volcano Observatory data that has not appeared in any previous eruption of this type in recorded history.
We will reach it before this report closes. Hold it in mind.
Kilauea is about to erupt again. Not a guess. Not a forecast built on intuition. A formal, instrument-verified prediction issued by the United States Geological Survey this morning places the onset of episode 49 between June 12 and June 15, with June 13 and June 14 carrying the highest probability. As this report is filed tonight, the summit of Halemaumau is glowing. The instruments are recording inflationary tilt at the Uekahuna station. The vents are releasing continuous gas plumes visible from the Kilauea Visitor Center. The volcano is not resting.
It is loading, and the instruments can show us exactly what that looks like.
But that is not the story we are filing tonight. The story is this. On the 1st of June 2026, when episode 48 ended after 9 hours of continuous lava fountaining, Kilauea crossed a line that no volcano of this type has ever crossed in the history of modern scientific monitoring. The number of discrete fountaining episodes in a single unbroken eruption sequence passed 47. That is the number held for decades by the Pu'u'o'o eruption, which ran from January 1983 to June 1986 across 47 documented episodes, and fundamentally altered the landscape of the Big Island, adding new land to the coastline and destroying more than 100 homes. That eruption defined what episodic fountaining on Kilauea looked like. It set the bar. Volcanologists used it as a reference point for everything that followed. The eruption that began on the 23rd of December 2024 in Halemaumau crater has now surpassed it. Episode 48 on the 1st of June 2026 pushed the count to 48. When episode 49 begins, as the instruments say it will between now and June 15, it will be 49. There is no prior model for what this means. The volcano has moved into territory the historical record does not cover. The Hawaiian Volcano Observatory is watching in real time as Kilauea writes a new chapter in its own file. Tonight's report examines what is happening inside that file right now. We will go through the current data in full. The inflation rates recorded at the summit tiltmeters since episode 48 ended, the gas emission readings from continuous monitoring stations, the seismic baseline, the thermal output from the active vents, and the precise geophysical signature that HVO is tracking as it builds blot episode 49. We will explain what each instrument measures, why the data it produces is authoritative, and what the current readings tell us about the timing and character of what is approaching. We will look at the history of this eruption series in detail, episode by episode, examining how the intervals and the intensity have shifted since December 2024. We will look at what the Pu'u'o'o comparison actually means in structural terms, what similarities exist and what differences the current eruption has introduced that make direct comparison complicated.
And then we will do what we do every night on this channel. We will go to a layer the science does not file.
There are 4 documented traditions that recorded what happens when fire erupts in counted intervals. When a mountain does not stop when the people watching expect it to stop. When the number of eruptions grows beyond the boundary of what was previously known. Each tradition made its record in a different language, on a different continent, in a different century. Each one was describing something real that the people who made the record witnessed or inherited from those who witnessed it. We will examine each one carefully and analytically. We will compare their language to the data on the board tonight. We will not tell you what to conclude. We give you the data, and we give you the record. What you do with both belongs to you. If this is your first time here, this is what we do every night. We file a report on a real event verified through official sources. We give you the full scientific picture. And then we go somewhere most channels do not. We look at the documented record of what human beings have observed and written down across 3,000 years of watching the same planet we are watching tonight. Subscribe if that is the kind of reporting you want. We file every night. drop a comment and tell us where you are watching from. If you are in Hawaii, if you can see the glow from where you are sitting, if you have been watching this eruption since it began in December 2024, we want to hear from you. That observation belongs in the record too. We should say, before the data begins, that this report does not attempt to predict the future. It does not tell you that something catastrophic is coming. It does not claim that the volcano is behaving in a way that poses an immediate threat beyond the hazard zones already defined by the National Park Service and Hawaii County Civil Defense. What it does is file the complete record. The record is more interesting than the alarm. The record shows a volcano doing something no volcano of this specific type has done before, in a location that human beings have been watching, writing about, and encoding into tradition for as long as human beings have lived on these islands. That observation, grounded in data and cross-referenced against what was documented before the data existed, is what this channel does every night. It is what we are doing tonight. The instruments are running. The data is current. Here is what the record shows. One more thing before the data begins, and it concerns the nature of what we are watching. Kilauea is not a dangerous volcano in the way that term is commonly understood. It does not produce the explosive eruptions that have defined volcanic disasters in human memory. It does not send pyroclastic flows across populated coastlines without warning. Its lava is slow enough, and the monitoring systems around it sophisticated enough that the communities in its path have time to move. The risk is real, but it is specific, and it is managed. What makes Kilauea significant for this report is not the danger it poses. What makes it significant is what it is doing. It is erupting in counted sequences that have now exceeded every prior count in the modern record. It is doing something new. And when something new happens in a place that has been watched and recorded for a very long time, there is value in checking what the older record says about it. That is the exercise tonight. The data first in full, the older record after, both of them together in the closing reflection. Let the two layers sit alongside each other and see what they produce. That is the whole method of this channel, and it is the method we use again tonight. The Halemaumau eruption began on the 23rd of December 2024, 18 months ago. It has not stopped. It has paused, repeatedly, in the way a piston pauses before it fires again. Each pause is an accumulation. Each episode is a release. The question the instruments are answering in real time tonight is when the next release will occur, and what its character will be. The tiltmeters have been running continuously since episode 48 ended. The gas sensors have not been turned off. The seismic network covers the entire summit region at a density that would have been technically impossible 30 years ago. We have more information about what is happening inside this volcano right now than any generation of observers before us has ever had. That is worth something. Use it. Subscribe if you want to be here when episode 49 begins. Subscribe if you want the report that crosses what the instruments show against what the older record says. We will be here. We file every night. Where are you watching from tonight? The briefing begins. On the 9th of June 2026, the Hawaiian Volcano Observatory issued its daily update confirming that Kilauea's summit eruption in Halemaumau remains paused following 9 hours of lava fountaining during episodic on June 8. Forecast models based on summit inflation rates indicate that episode 49 of lava fountaining is likely to occur between June 12 and June 15, with June 13 and June 14 identified as the most probable onset window. The current volcano alert level is advisory. The aviation color code is yellow. No significant activity has been noted along Kilauea's East Rift Zone or Southwest Rift Zone. The eruption remains confined to the summit caldera. That is the official status as of tonight. Now here is what the status means. The Hawaiian Volcano Observatory is the oldest volcanological monitoring institution in the United States. It was established in 1912 on the rim of Kilauea's summit caldera by Thomas Jagger, a geologist from the Massachusetts Institute of Technology who watched the 1906 San Francisco earthquake and decided that the world needed permanent stations sitting directly on top of active volcanoes rather than trying to interpret them from a distance after the fact. The HVO has been continuously monitoring Kilauea for more than a century. Its network today includes hundreds of seismometers, tiltmeters, GPS stations, gas sensors, webcams, and thermal imaging systems distributed across the Big Island. When HVO issues a forecast, it is drawing on real-time data from all of those instruments simultaneously. When HVO says episode 49 is expected between June 12 and June 15, with June 13 to 14 most likely, that is not an educated guess. That is a physics-based model being fed live data from instruments mounted on and around an active volcano. The model has been trained on 48 prior episodes from this specific eruption. It knows what the volcano looks like before it erupts. It is looking at that signature right now. The specific instrument driving the episode 49 forecast is the tiltmeter. A tiltmeter is exactly what its name suggests, an instrument that measures the tilt of the ground surface with extreme precision, detecting changes as small as a fraction of a microradian. 1 microradian is approximately the angle you would observe if one end of a kilometer-long board rose by 1 millimeter. The tiltmeter at Uekahuna, abbreviated UWD in HVO's notation system and located on the northwest rim of the summit caldera, is the primary station for tracking Kilauea's magma supply and storage fluctuations. When magma is accumulating in the summit reservoir beneath Halemaumau, the ground above it inflates and the tiltmeter records a rising trend. When an eruption begins and magma drains from the reservoir into the erupting vent, the ground deflates and the tiltmeter records a falling trend. The transition between inflation and deflation, and the rate and shape of that transition, is the signal HVO is reading to build its eruption forecast. At the end of episode 48, on the 1st of June 2026, the summit tiltmeter recorded a total deflation of 17.1 microradians during the 9 hours of fountaining. When the eruption ended at 1:37 p.m. Hawaii Standard Time, inflation immediately resumed. By June 4, the tiltmeter had recovered 6.2 microradians of the deflation. By June 9, the recovery had continued, building steadily along a curve that the HVO forecast models recognize as the precursor pattern for an imminent episode. The models compare the current inflation rate and total recovered tilt against the same measurements from prior episodes and calculate when the system will reach the threshold that has preceded each previous eruption. That calculation produced the June 12 to 15 window. That is the number driving tonight's forecast. The gas data tells a parallel story. Kilauea emits sulfur dioxide continuously from its active vents, and the emission rate is a direct proxy for the amount of magma degassing near the surface. During an active eruption episode, sulfur dioxide emission rates spike to tens of thousands of tons per day. Between episodes, the rate drops, but does not fall to zero. The continuous emissions during the current pause, combined with the visible gas plumes reported by HVO observers at the summit throughout this week, indicate that the active magmatic system immediately below the vent remains pressurized and connected to the deeper supply. The plume is visible in daylight from the Kilauea Visitor Center and produces bright glow at night. That glow is not residual heat from episode 48's lava.
It is active emission from a vent that is not closed. It is the system telling you it is not finished.
Here is the record-breaking context, and here is the number that has not appeared before. The eruption that began on the 23rd of December 2024 has now produced 48 discrete lava fountaining episodes. Each episode is defined by a period of continuous active lava fountaining from the summit vents, typically lasting from a few hours to a few days, followed by a pause during which the summit reservoir reinflates before the next episode. The previous record for the most fountaining episodes in a single episodic eruption of this type belonged to the Pu'u'o'o eruption, which ran from the 3rd of January 1983 to the 26th of June 2018, and produced 47 distinct high fountaining episodes in its first 3 years, before transitioning to a different eruptive style involving continuous lava lake activity and tube-fed surface flows. Those 47 episodes set the benchmark. No subsequent eruption anywhere on Kilauea matched it in terms of discrete fountain count within a single eruptive sequence. The current eruption matched it with episode 47 on the 26th of May 2026. It surpassed it with episode 48 on June 1. The HVO's official documentation notes this milestone directly. The Halemaumau eruption now holds the record for the most fountaining episodes ever recorded for an episodic fountaining eruption. This is not an informal observation. It is in the scientific record. And when episode 49 begins, the count will extend further into territory that has no prior data. The character of episode 48 itself merits a detailed examination before we move forward. On the morning of the 1st of June 2026, at 4:40 a.m. Hawaii Standard Time, fountaining began at the North Vent in Halemaumau.
By the time the eruption reached its peak activity, several hours later, lava fountains from the North Vent were reaching a maximum height of approximately 650 feet,
or roughly 200 meters, above the crater floor. The South Vent remained active, but at lower intensity, throughout the episode. Lava flows from the North Vent spread across the crater floor and covered approximately 40% of its total area by the time the episode ended. The plume produced by the fountaining reached approximately 25,000 feet above sea level. Ash and tephra, the fragmented volcanic material launched into the air by the fountains, fell across a corridor within Hawaii Volcanoes National Park and extended onto Highway 11, into the communities of Volcano Village, Mauna Loa Estates, and Ohia Estates, and reached as far as Mountain View on the Hamakua coast. Reticulite, a fragile glassy volcanic foam produced by intense fountaining, was reported at the Uekahuna Overlook and at Namakanipaio Campground, with pieces up to approximately 1 inch in diameter. A sulfur and ash cloud formed near Laupauhei on the Hamakua coast. Several morning flights to Hilo were canceled or diverted as a result of the ash and gas in the approach corridor. The eruption ended at 1:37 p.m. Hawaii Standard Time on June 1. Total duration, 9 hours. Total lava volume, not yet formally calculated by HVO for episode 48, but based on earlier episodes of comparable duration and vent intensity, estimated in the multi-million cubic yard range, consistent with episode 47's output. The seismic record accompanying episode 48's end is worth noting specifically. As the eruption concluded, approximately 50 earthquakes, most smaller than magnitude 2, occurred in rapid succession at depths up to about 1.5 kilometers below the south rim of Halemaumau. An area along the south rim also rose by several centimeters as measured by the COSMO-SkyMed second-generation satellite's interferometric synthetic aperture radar system, which detected ground deformation in the period from May 25 to June 2. HVO has stated that the specific cause of that localized uplift at the south rim remains under investigation,
noting it could be related to magma movement in a pathway separate from the main eruption vent.
That second data point, the unresolved south rim deformation, is a detail the agencies have not fully addressed publicly. It will matter later in this report. Keep it in mind. The full context of the current eruption sequence requires understanding what changed between the beginning of the eruption in December 2024 and where the system stands tonight. The eruption began during what HVO had categorized as a period of elevated activity at the summit following the end of a prior lava lake phase. The first episodes in December 2024 and January 2025 were relatively brief, often lasting only a few hours, with pause intervals of several days to a few weeks. Over the course of 2025 and into 2026, the pattern shifted. Episodes became longer, sometimes extending to multiple days. pause intervals between episodes shortened in aggregate, though not monotonically. The lava volumes per episode increased. The fountain heights at the north vent grew progressively more impressive through the spring of 2026. By the time the eruption passed its 40th episode, it was producing events that individual episodes of the Pu'u'o'o eruption rarely matched in terms of raw fountain height and lava coverage per event. The USGS's eruptive episode database for this eruption, maintained by HVO and publicly accessible, shows the full chronology. Each episode is individually characterized: onset time, duration, maximum fountain height, primary vents active, associated seismicity, tilt response, and gas emission levels. That database now contains 48 entries. Each entry represents an individual geophysical event of sufficient scale to be classified by HVO as a distinct eruptive episode. The cumulative energy represented by those 48 entries, the total volume of magma that has been moved from the deep supply through the summit reservoir and out through the vents, represents a significant fraction of the island's ongoing volcanic budget. Kilauea is not a system that is exhausting itself. It is a system that is running, and the data suggests it intends to continue running. The monitoring infrastructure watching it extends beyond the HVO network. The United States Geological Survey coordinates with NASA, with the European Space Agency's Sentinel satellite program, and with the Italian Space Agency's COSMO-SkyMed constellation to track surface deformation. The Japan Aerospace Exploration Agency has historically contributed radar monitoring data for Kilauea as well. The National Oceanic and Atmospheric Administration monitors sulfur dioxide dispersion and aviation hazard in coordination with the Volcanic Ash Advisory Center in Washington. The FAA and the Hawaii Department of Transportation receive direct notification from HVO whenever an eruptive episode begins. This is a volcano with more institutional eyes on it than almost any other volcano on Earth. What those institutional eyes are watching tonight is the inflation trend. 6.2 microradians of tilt recovery recorded at Uekahuna since the end of episode 48. The curve continues rising. The forecast models, having been validated against 48 prior episodes in this specific eruption sequence, are converging on a 4-day window beginning 3 days from tonight. When the inflation curve crosses the threshold value, the system will likely begin fountaining again. The instruments will see it before any human observer does. HVO will issue a notification. The lava will emerge from the north vent, and the sequence that started on the 23rd of December 2024 will extend its record by one more episode, episode 49, the number that has never existed in this specific scientific context before. There is also the question of what happens after episode 49. The eruption's trajectory raises a set of questions that HVO scientists have addressed in public documentation with measured language that is worth reading carefully. The USGS has noted that Kilauea's summit eruption appears to be sustained by a magma supply rate that has not declined significantly since the eruption began. The summit reservoir is refilling after each episode at rates consistent with continued deep magma supply from the volcanic hotspot system beneath the Pacific Plate. There is no instrument data indicating that the supply is diminishing. The system is not losing pressure. It is cycling between eruption and recharge in a pattern that has now been calibrated across 48 data points. That pattern has not converged toward an endpoint. It has converged toward continuation. The geologically meaningful question, the one that the 48 episodes and the upcoming episode 49 collectively raise, is whether the current eruption represents a transitional phase in Kilauea's volcanic cycle, or a sustained mode that will continue indefinitely in something close to its current form. The Pu'u'o'o eruption is instructive here, but only partially. That eruption did not stop at 47 episodes. It transitioned. The high fountaining phase gave way to a continuous effusive phase in which lava was supplied through underground tubes and emerged at the coastline, building new land for more than 30 years before the eruption finally ceased in 2018. The current eruption has not yet made that transition. It continues to operate in the discrete episodic fountaining mode it has exhibited since December 2024. Whether it will transition, and if so to what, is a question the instruments cannot yet answer. That is also on the record. That is also worth noting. The South Rim deformation is the data point that has not been resolved. We mentioned it. We will return to it. By the end of this report, you will understand why it matters not just geophysically, but in the context of the older record we are about to examine. The agency has not commented publicly on what it means. The data is in the file. We are in observation mode. We continue to monitor. Let us go deeper into the physical mechanics of what is happening inside Halemaumau tonight, because the numbers alone do not fully convey the scale of what the instruments are measuring. Kilauea summit caldera sits at approximately 1,247 meters above sea level at the current crater rim. The crater floor of Halemaumau, which has been dramatically reshaped by the ongoing eruption, lies hundreds of meters below the rim in places. The active vents, designated the North Vent and the South Vent in HVO's notation, sit at the crater floor. When lava fountains from the North Vent reached 650 feet during episode 48, they were projecting material more than 200 meters above the vent, which was itself already deep within the caldera. From the overlook points accessible to visitors in Hawaii Volcanoes National Park, the fountains appeared as columns of incandescent orange and red material rising to or above the rim of the inner crater. The photographs and video recorded by HVO webcams during episode 48 show a visual intensity consistent with the most spectacular individual episodes in the entire eruption sequence. The lava covering the crater floor represents a continuously accumulating record of eruptive activity. Each episode deposits new material, buries the flows from prior episodes, and reshapes the floor geometry. The total accumulated lava volume from 48 episodes of this eruption represents a significant addition to the existing lava pile that fills and refills Halemaumau on. Geological timescales. HVO scientists estimate, based on mapping using satellite radar and photogrammetry from HVO drone flights, that the crater floor has been substantially raised since December 2024. The geometry of the active system, including the dimensions of the active vent openings and the channels through which lava travels across the crater floor, changes from episode to episode. HVO publishes updated maps after each significant episode. Those maps are part of the scientific record, and they show, collectively, a crater floor that has been profoundly transformed in 18 months of activity. The magma supply system feeding this eruption extends far below the summit caldera. Kilauea is built above a hot spot in the Pacific Plate, a stationary source of deep mantle heat that has been producing volcanic output for tens of millions of years as the Pacific Plate moved northwest across it. The chain of Hawaiian islands and seamounts extending northwest from the current position of the Big Island represents the geological trail of that hot spot. Each island, progressively older, more eroded, and more distant from the active volcanic center as the plate carried it away. The Big Island itself is young in geological terms, and the hot spot currently sits beneath its southern portion, driving active volcanism at both Kilauea and Mauna Loa. The magma that erupts from Kilauea's summit vents originates from depths of tens to hundreds of kilometers, where partial melting of the mantle produces basaltic magma that rises through a complex network of conduits and storage zones before reaching the shallow summit reservoir. The shallow summit reservoir, the magma body that inflates and deflates with each eruption cycle, is estimated by geophysical inversion modeling to sit at depths of roughly 2 to 4 kilometers beneath the surface of the summit caldera. HVO's GPS network, which measures three-dimensional ground movement with centimeter-scale precision, tracks the inflation and deflation of the ground above this reservoir in all directions simultaneously. When the reservoir is filling, the GPS stations spread outward slightly and rise. When it empties during an eruption, they converge and drop. The tiltmeter signal at Uekahuna is essentially measuring the edge of this deformation field with higher temporal resolution than the GPS can provide. Together, the tilt and GPS data paint a quantitative picture of how much magma is in the shallow reservoir at any given moment and how fast it is changing. The current picture, as of tonight, shows a reservoir that is approximately 36% refilled relative to the deflation that occurred during episode 48. The 17.1 microradians of deflation during episode 48 represented the magma that erupted during those 9 hours. The 6.2 microradians of reinflation since then represents the magma that has been supplied from the deeper system to replace it. The forecast models use the ratio of current inflation to the total deflation from the preceding episode, combined with the rate of inflation, to estimate when the reservoir will reach the threshold that has preceded eruption onset in prior episodes. At the current rate, that threshold falls in the June 12 to 15 window. That is why the forecast says what it says. The broader eruption context includes a comparison that is worth making explicitly. The current eruption, at 48 episodes and counting, is the longest episodic fountaining eruption in Kilauea's modern record. But it is not the longest eruption in Kilauea's modern record. The Pu'u'o'o eruption ran continuously for 35 years, from 1983 to 2018. It produced 47 high fountaining episodes in its initial phase, then transitioned to a different mode of activity. The current eruption is still in its initial episodic phase after 18 months. Whether it transitions to a different mode of activity, and when, remains an open question. What can be said is that the current system is operating in a sustained and repeating pattern that the historical record has never produced in the same form. There is an additional geological context that the current eruption illuminates. Kilauea has erupted in episodic fountaining sequences before the current one, before the Pu'u'o'o eruption, before the era of modern continuous monitoring. The geological record preserved in the lava stratigraphy of the Big Island contains evidence of past eruption sequences whose frequency and duration can be inferred from the physical characteristics of the deposits. The Kilauea eruption of 1959, which produced the lava lake that still occupies that adjacent crater today, was a single episode of extraordinary intensity. 19 days of high fountaining from a single vent, with fountain heights reaching 1,900 feet, the highest ever recorded at Kilauea. But it was a single event, not a sequence. The current eruption is a sequence. That difference in character is geologically meaningful. It suggests a different mode of magma supply and reservoir cycling than the intense individual events of the past century. The historical eruption record for Kilauea, compiled by HVO scientists from written accounts, geological mapping, oral traditions, and instrumental records going back to 1823, shows that the volcano has been continuously or intermittently erupting for the entire period of human observation. The summit caldera has hosted lava lakes, explosive eruptions, lava overflow events, and extended quiet periods. The relationship between summit activity and rift zone activity, including the major eruptions on the East Rift Zone and Southwest Rift Zone that have threatened communities on the Big Island at various points in the 20th and 21st centuries, is complex and not fully predictable. The current eruption at the summit does not preclude rift zone activity. HVO monitors both simultaneously. Tonight, the rift zones are quiet. The summit is loading. The 1,924 explosive eruption at Kilauea's summit is a reference point that HVO scientists keep in view when describing the potential range of eruption styles the volcano can produce. That eruption occurred when the lava lake that had occupied Halemaumau since the early 20th century suddenly drained into the East Rift Zone,
allowing groundwater to contact the hot magmatic system and producing a series of phreatic explosions that threw large ballistic blocks onto the rim of the caldera and generated ash clouds that fell on the surrounding communities.
The 1924 eruption was not anticipated by the limited monitoring capabilities of the time. It is one reason that HVO's monitoring network is as comprehensive as it is today. The probability of a similar event occurring during or after the current eruption sequence is considered low by HVO scientists, who note that the current system is erupting efficiently through open vents rather than building the conditions that preceded the 1924 event.
But the possibility is in the file. It is in the hazard assessment. It is part of what the instruments are watching for.
The 2018 Lower East Rift Zone eruption is the more recent reference point for the scale of disruption that Kilauea can produce when conditions change. That eruption began in May 2018 and ran through August 2018,
producing lava flows that destroyed more than 700 homes in the Leilani Estates and Lanipuna Gardens subdivisions in the Lower East Rift Zone.
The flows buried roads, covered a geothermal energy facility, and added approximately 875 acres of new land to the Big Island's southern coastline. The 2018 eruption was triggered by a combination of factors including magma drainage from the summit reservoir and an intrusion into the lower rift zone. The summit activity that preceded it in 2018 included a lava lake in Halemaumau that had been maintained for years. That lake drained rapidly when the rift zone intrusion began. The current eruption is not currently producing rift zone activity, and HVO's monitoring shows no signs of an active intrusion. The East Rift Zone and Southwest Rift Zone are both showing background seismicity levels and ground deformation rates consistent with a system that is not being pressurized by a round directed intrusion. This is a material difference from the conditions that preceded the 2018 event. It does not guarantee that rift zone activity will not occur during the current eruption's lifetime, but it means that the current situation is not matching the 2018 precursor pattern in the data that the instruments are seeing tonight. The 2018 comparison also raises a question about what the current eruption's eventual conclusion might look like. If the summit system transitions from episodic high fountaining to a continuous effusive phase, the risk profile for communities on the rift zones changes.
If the summit system transitions to a phase of reduced activity or quiescence,
the magma that has been cycling through the summit reservoir might begin to accumulate pressure in the rift zones instead. These are not predictions. They are the logical extensions of the known physics of the system, and they are the questions that HVO scientists are monitoring for at all times. For tonight, the question the instruments are answering is simpler and more immediate. When does episode 49 begin? The tiltmeter at Uekahuna is recording a rising trend. The gas sensors are showing continuous active emission. The seismic network is registering the low-frequency pulsing that is typical of the inter-episode pause at Kilauea's summit. The webcam at the south rim of the caldera shows glow at night from the active vents. Everything in the data is consistent with an eruption that is paused and building toward its next cycle. The number will be 49. It will be in the file by the time this weekend ends. We will be here. Before we leave the briefing and move into the historical record, there is one more piece of current data worth noting, and it connects directly to the South Rim deformation we mentioned earlier. HVO scientists analyzing the InSAR data from the COSMO-SkyMed satellite imagery covering the period from May 25 to the 2nd of June 2026 noted localized ground deformation on the south rim of Halemaumau that was distinct from the broad caldera deformation associated with the eruption itself. The localized deformation in the south rim area represents a signal that does not fit cleanly into the standard inflation-deflation model for the main eruption vent. HVO has flagged it and described its cause as uncertain, noting it could be related to magma movement in a pathway that is not the primary eruption conduit. That pathway, if it exists, would represent a secondary magmatic feature within the summit caldera system. Its significance is not yet clear. Its existence is in the data. That number, the south rim signal, is the piece of the current monitoring picture that the agencies have not yet resolved. We will return to it one more time before this report closes. The monitoring systems watching Kilauea tonight are the product of more than a century of institutional knowledge building about how this specific volcano behaves. That knowledge building did not begin with Thomas Jagger in 1912, though his founding of the HVO gave it a formal scientific institutional structure. Before Jagger, there was a record. It was not an instrumental record. It was a natural, historical, and observational record kept by people who had been watching Kilauea since long before the United States existed as a nation, since long before Western scientific methods arrived on these islands. That record begins with what the people who lived on the Big Island observed, documented, and transmitted. It is the foundation layer beneath the instrumental record, and it goes back centuries further than any seismometer does. The Western observational record of Kilauea begins in 1823 with the missionary William Ellis, who became the first documented Western visitor to Halemaumau, and recorded his account of a lava lake in the summit crater in his narrative, published in 1827. Ellis described a vast, illuminated pool of molten rock in the pit of the caldera, with constant activity at the surface and intermittent fountaining at the edges of the lake. His account was corroborated by subsequent visitors throughout the 19th century, including the American writer Mark Twain, who visited in 1866 and published a vivid account of the lava lake in his book Roughing It. The geological record and the oral record both suggest that the lava lake that Ellis and Twain observed was part of a continuous or near-continuous eruptive system that had been operating at Kilauea's summit for much of the 18th and 19th centuries. The historical record of summit lava lake activity in Halemaumau extends back at least to the mid-18th century, based on accounts preserved in Hawaiian oral tradition and in the earliest missionary and traveler accounts. The 1,790 explosive eruption at Kilauea's summit, which occurred during a period of intense activity that also coincided with a military campaign by the Hawaiian chief Keoaquahu'ula, is documented in both Western historical accounts and in the oral traditions preserved by native Hawaiian communities.
A group of Kiowa's warriors and their families, estimated at approximately 80 people,
died in the eruption, or in the immediate aftermath of exposure to volcanic gases and ashfall. The account of this event,
transmitted in Hawaiian oral tradition and corroborated by footprints preserved in the ashfall deposits that have been geologically dated to approximately 1,790,
represents one of the most significant documented cases of volcanic mortality in Hawaiian history.
It also represents the kind of direct human experience of volcanic activity that generates oral tradition, ritual observation, and documented cultural response. The volcano was not an abstract phenomenon to the people who lived with it. It was present, active, and consequential. They watched it. They recorded what they saw. The geological record beneath Kilauea's current summit eruption extends far deeper than the 1,790 event. Drill cores taken from the flanks of the volcano and from the caldera floor have recovered volcanic deposits spanning thousands of years. The pattern of eruptions recorded in those cores shows that Kilauea has been erupting repeatedly, in various styles and at various intensities, throughout the entire period of human habitation of the Hawaiian Islands. The current eruption is the most recent chapter in a geological record that extends back through hundreds of thousands of years of hotspot volcanism. The volcano does not operate on human timescales. It operates on geological timescales. The 48 episodes of the current eruption are, in geological terms, a brief pulse. The record beneath Halemaumau contains evidence of eruptions far more voluminous, far more prolonged, and far more transformative than anything the current monitoring period has documented. The instruments are watching a young volcano doing what young volcanoes on active hotspots do. That geological perspective is not a reason to minimize tonight's data. It is a reason to contextualize it. The current eruption is historically significant by the standards of the modern monitoring era, which began in earnest with the founding of HVO in 1912 and has been building in instrumental sophistication ever since. Within that modern era, the 48 episodes and the upcoming 49th represent an unprecedented sequence. No monitoring agency has tracked a fountaining eruption of this specific type through this many discrete episodes within a single unbroken eruptive sequence. The data is in the file because the event has never reached this point before. The record being made right now is new territory for the scientific institutions watching it. The question that the older record addresses, the question that the traditions we are about to examine took seriously, is not how many episodes have occurred in the monitoring period. It is what the eruption means.
What does it mean when the fire in the mountain counts its returns?
When the intervals between eruptions shorten and then lengthen again, and then shorten again in patterns that do not stabilize. When the number of episodes exceeds the expectation of the people watching. Different cultures, separated by thousands of miles and thousands of years, answered that question in ways that are worth examining. They were observing real volcanic phenomena. They were encoding what they saw in the most durable forms available to them. The records they left are not prediction in the modern sense. They are documentation. They are the older layer of the file on the same event. We will move to the historical parallels now, and then to those traditions directly. The data briefing is complete. The South Rim signal is in the file. Episode 49 is incoming. The number will be 49. To reach the full instrument picture that HVO has on the table tonight, we need to address one more monitoring system and what it is showing. The seismic network at Kilauea's summit is the deepest layer of real-time information about the state of the volcanic system. Where the tiltmeter and GPS measure surface deformation, the seismometers measure the movement of rock and fluid deep within the volcanic edifice. The pattern of seismicity at Kilauea during an inter-episode pause has a characteristic signature that HVO scientists recognize as a reliable indicator of where the system is in. The eruption cycle. During an active eruption episode, the seismic signal at the summit is dominated by harmonic tremor, a sustained, quasi-sinusoidal vibration produced by magma and gas moving through conduits under pressure. This tremor is distinct from the sharp, impulsive signals produced by fault rupture earthquakes. When the eruption ends, the tremor ceases and the seismic record transitions to a quieter state, punctuated by the low-frequency seismic pulsing that HVO describes as gas pistoning. Gas pistoning is produced by the cyclic pressurization and release of gas pockets within the active vent system.
It sounds, on the seismogram, like slow, regular oscillations occurring at intervals of minutes to tens of minutes. It is the volcanic equivalent of a sleeping giant breathing.
The current seismic record at Kilauea's summit is showing this gas pistoning signature, consistent with a system in the active inter-episode pause phase rather than quiescence. The shallow seismicity beneath the south rim of Halemaumau, the 50 earthquakes that occurred as episode 48 ended on June 1, is also still being analyzed. Those earthquakes occurred at depths of less than 1.5 kilometers below the surface, making them very shallow in volcanic terms. Their spatial distribution, concentrated beneath the south rim rather than directly beneath the active north vent, is part of what makes the associated ground deformation signal difficult to interpret within the standard eruption model. HVO has not resolved this signal in its public communications since June 1. The question of what produced it remains open. That open question is what makes the South Rim signal the most interesting piece of current data in the HVO file, and it is the piece we want to carry forward into the rest of tonight's report. There is a second institutional lens worth placing on tonight's event before we transition to the historical record. The Smithsonian Institution's Global Volcanism Program, which maintains the world's most comprehensive database of volcanic activity and produces weekly reports on ongoing eruptions worldwide, includes Kilauea in its current eruptions list, and has tracked the current eruption sequence continuously since December 2024. The GVP's weekly volcanic activity reports, compiled by geoscientists at the Smithsonian's National Museum of Natural History and at the USGS, provide a parallel institutional record of the eruption that cross-references against HVO's local data. The GVP's characterization of the current eruption in its most recent weekly report, covering the period through the 3rd of June 2026, notes the record-breaking episode count and the continued inflation trend consistent with an imminent episode 49. The GVP's global database also provides context for how the current Kilauea eruption compares to other significant episodic eruptions documented worldwide. In terms of discrete episode count within a single unbroken sequence, the current Kilauea eruption is without a documented global peer in the modern monitoring era. What this means in practical terms for the people living on and around the Big Island is a question that HVO and Hawaii County Civil Defense address continuously. The current eruption poses direct hazard primarily within the closed area of Hawaii Volcanoes National Park and potentially within areas immediately downslope from the summit caldera in scenarios involving lava overflow. The volcanic gases produced by the eruption, particularly sulfur dioxide and the sulfuric acid aerosols it forms in the atmosphere, produce the VOG, volcanic smog, that affects air quality across the Hawaiian Islands and occasionally reaches concentrations that are problematic for people with respiratory conditions. HVO issues volcanic air quality advisories when sulfur dioxide emission rates and wind conditions combine to produce hazardous VOG concentrations at ground level in populated areas. The current eruption's gas output has been high enough throughout its history to produce periodic significant VOG events on the Big Island and on other islands in the chain. The lava flows within the active eruption zone are the most visually dramatic aspect of the eruption for those who can see them. But they are not the primary hazard concern for most communities, because the flows are confined within the national park boundaries in the current configuration. The hazard that would change that calculation is a rift zone intrusion, the scenario that produced the 2018 disaster. The data tonight does not support the expectation of an imminent rift zone intrusion. The data tonight supports the expectation of a continuing summit eruption that will produce episode 49 within the next 6 days. That is the complete current instrument picture. Tiltmeter. Rising inflation trend. 36% of episode 48 deflation recovered. Trajectory pointing to June 12 to 15 onset. Seismometers. Inter-episode gas piston signature. Background volcanic seismicity. Unresolved south rim shallow seismicity from June 1. GPS. Broad inflationary deformation consistent with magma recharge of the shallow summit reservoir, plus localized south rim deformation that is not fully characterized. Gas sensors. Continuous sulfur dioxide emission. Robust visible and thermal plumes. Active venting from north and south vents. Webcams. Continuous nighttime glow. Daytime degassing plume visible from visitor center. Satellite radar. InSAR deformation map from COSMO-SkyMed showing both the broad summit inflation and the localized south rim signal. Every instrument is telling the same story. The volcano is loading. The system is active. The next episode is imminent.
And the south rim signal is telling a slightly different story. There is something in the subvent system that the standard model does not yet account for.
That number, that anomaly, is what connects the current instrumental record to the historical record we are about to examine, and it is what connects both of those layers to the ancient record that comes after. The complete eruption sequence from the 23rd of December 2024 to the present has produced something that can be quantified, but that the numbers alone do not fully capture. 48 events, each one a discrete geophysical episode in which the Earth opened at the floor of the summit caldera and released heat and material that had been accumulating since the last opening. Each one followed by a closing, a pause, a recharge, and then another opening. The pattern is mechanical at its core, a reservoir filling and emptying, over and over again, in a cycle that the physics of magma supply and crustal pressure dictate. But the pattern is also, at its count of 48 and climbing, without precedent in the modern record of this type of eruption. It is a number that exists in only one place in the world's scientific record, in the HVO database for the current Kilauea eruption. The interval structure of those 48 episodes is worth examining one more time before we leave the briefing data. The pauses between episodes have ranged from a few hours to more than 3 weeks across the eruption's history. There is no simple linear trend in pause duration across all 48 episodes, but there are periods within the eruption's history when the intervals compressed significantly, and periods when they extended. The current pause following episode 48 has been running for 9 days as of tonight. That is not the longest inter-episode interval in the eruption's history, nor the shortest. It falls within the range the system has exhibited before. The forecast model's projection of June 12 to 15 onset suggests the system will produce the 49th episode after approximately 11 to 14 days of recharge, which is entirely consistent with the inter-episode interval distribution observed across the prior 48 cycles.
What is not consistent with prior observation is what the instruments will be recording when that 49th episode begins, a count that has never existed before.
The instruments will detect it, HVO will announce it, the webcams will record it, the satellite will image it, and the volcanic system beneath Halemaumau will have once again done something that the historical record had, until this year, never contained. That is the briefing. The data is on file. The transition to the historical record begins now. Before that transition, we will note one additional piece of data that becomes relevant in the context of what follows. The north vent in Halemaumau is not a new feature of the landscape. It has been intermittently active across multiple eruption cycles in Kilauea's history. The pit that currently constitutes the inner portion of Halemaumau, the space within which the lava has been fountaining and pooling since December 2024, has a documented history extending back through the continuous monitoring period and into the geological record before that. It has contained lava lakes. It has been the site of explosive eruptions. It has been quiet for extended periods. The 2018 eruption caused the collapse of the crater floor into the withdrawing magma column, fundamentally reshaping Halemaumau into the deep pit that currently contains the active vents. The floor that has been accumulating lava since December 2024 is being built atop the rubble of that 2018 collapse. The north vent is erupting into a space that was dramatically reconfigured less than a decade ago. The volcano is building on its own recent history. That is the physical reality the instruments are measuring tonight. The number is 48. It will be 49. The window is June 12 to 15. Everything else the instruments are showing is consistent with the arrival of that number on schedule. The data is on the record. We move now to what came before the instruments. The eruption history of the Hawaiian Islands, recorded both in the geological stratigraphy and in the institutional documentation of the modern era, shows that Kilauea is not the most powerful or destructive volcano in the world by any standard metric. It is not the most voluminous. It is not the most explosive. It is not the most dangerous to the largest number of people. What it is, by any measure, is the most continuously monitored and the most extensively documented volcano on Earth. The combination of its location on the territory of a nation with the technical and financial resources to build and maintain a first-class monitoring infrastructure, its relative accessibility to researchers and observers, and its consistent productivity over the entire modern era has made it the most studied volcano in history. The data on Kilauea is more complete than the data on any other volcanic system, and that completeness is precisely why the current eruption's record-breaking count is meaningful, because the data that establishes what is unprecedented is itself the most comprehensive dataset of its kind in the world. The 48 episodes in this eruption are not unprecedented simply because no one was watching closely enough to count before. They are unprecedented because HVO has been counting meticulously and continuously since 1912. And through all of that counting, through all of the eruptions and episodes and swarms and intrusions documented in the HVO record, nothing has produced this specific sequence. The count of 48 is real and it is exhaustive, and it is the correct number. The count of 49, when it comes, will extend it further. That is the full briefing. The instruments are running. The data is current. We move now to the historical record. One more figure before we turn the page. The total lava volume produced by the 48 episodes of the current eruption has not yet been formally tabulated by HVO in a single comprehensive number, but individual episode data and cumulative flow mapping studies suggest it runs into the hundreds of millions of cubic yards of extruded basaltic lava. The crater floor of Halemaumau has been raised by an estimated several tens of meters since December 2024 through the accumulation of lava flows from 48 episodes. The thermal energy released by each episode, given the temperature of erupting Hawaiian basalt at approximately 1,150 degrees Celsius and the volumes involved, is enormous by any engineering standard. Each episode is not simply a visible event at the surface. It is a geothermal energy release of a scale that has measurable secondary effects. Elevated ground temperatures in the caldera region, altered circulation patterns in the geothermal aquifer beneath the volcanic edifice, and changes to the local groundwater chemistry that HVO monitors through its network of gas and fluid sampling stations. All of those secondary effects are currently being recorded. All of that data is in the file. The volcano is not simply erupting. It is reorganizing the thermal and fluid environment of the summit region with each cycle. That reorganization, that physical transformation of the environment around an active vent through repeated eruption cycles,
is the kind of observation that the ancient record encoded in ways that predate our instruments.
The people who watched volcanic systems through dozens and hundreds of eruption cycles over centuries and millennia were observing real physical change in real landscape. They were not observing supernatural events. They were observing geology at human timescales, and they made records of what they saw. Those records are next. There is also the question of what the global monitoring community is watching on the wider Hawaiian system as the current eruption extends into its record-breaking territory. The Hawaiian archipelago is not merely Kilauea. Mauna Loa, the largest volcano on Earth by volume, that's adjacent to Kilauea on the Big Island and shares the same deep hotspot magmatic source. Mauna Loa last erupted in November and December 2022, producing flows that advanced toward communities in the Saddle Road area before stopping. The USGS monitors Mauna Loa through a separate but complementary monitoring network, and the current status of Mauna Loa is non-erupting at advisory level. The interaction between the magmatic systems of Kilauea and Mauna Loa is a subject of active research. Historically, periods of intense activity at Kilauea's summit have sometimes been followed by activity at Mauna Loa, and vice versa, although the relationship is not deterministic and the mechanisms are not fully characterized. The current period of sustained and record-breaking summit activity at Kilauea has not yet produced any instrument signal indicating imminent activity at Mauna Loa. HVO monitors both simultaneously and has issued no Mauna Loa watch or warning. That data is also in the file, and its absence, the absence of any Mauna Loa signal, is as meaningful as its presence would be. The full instrument picture across both systems is Kilauea loading toward episode 49, Mauna Loa quiet, rift zones on both systems at background levels. No signals of an imminent shift in the current pattern beyond the predictable arrival of the next Kilauea summit episode on schedule. That is the broadest context in which tonight's event sits. The Big Island is the youngest and most volcanically active land on Earth. It is being built in real time. The process doing the building is what the instruments are measuring tonight. and the process being recorded has been going on, in various forms, for every generation of human beings who have lived on these islands. Now, to the record those generations left. There is one more monitoring dimension that is worth including in the briefing before we close it. The role of the National Park Service in managing the human dimension of the current eruption is a parallel institutional story that the HVO instrumental data does not fully capture. Hawaii Volcanoes National Park, which surrounds the summit caldera of Kilauea, has been managing public access to the eruption throughout the 48 episodes of the current sequence. The park's visitor infrastructure has been significantly affected by the eruption. Specific overlook areas have been opened and closed depending on the location and intensity of activity. Ashfall and tephra deposition from high fountaining episodes has required periodic closure of roads and trails, and the volcanic gas hazard from sulfur dioxide emission during active eruption phases requires monitoring of visitor areas for air quality. The park maintains a real-time volcanic air quality monitoring network in conjunction with HVO and the Hawaii State Department of Health. The visitor data for Hawaii Volcanoes National Park during the current eruption sequence is itself a form of documentation. The park has reported record visitation during active eruption phases, with large numbers of people traveling to the Big Island specifically to observe the summit fountaining. The eruption has become one of the most viewed geological events in the park's history. The webcam feeds from the caldera rim that HVO maintains for scientific monitoring purposes have also attracted significant public viewership, with live stream audiences reaching tens of thousands during active episode peaks. The current eruption is simultaneously a scientific event, a management challenge, and a public spectacle, and all three of those dimensions are part of the record that will eventually describe what happened at Kilauea between December 2024 and whenever the current eruption finally ends. The public observation component of the current eruption connects, in a way that is worth noting, to the tradition of public observation of Kilauea that extends back through the entire written historical record on the islands. The visitors who come to the caldera rim today to watch the fountains are participating in an activity that missionaries, scientists, writers, and curious travelers have been doing since the 19th century. Mark Twain watched the lava lake in 1866 and wrote about it for a popular American audience. Isabella Bird, the Victorian travel writer, visited Kilauea in 1873 and published her account in 6 months in the Sandwich Islands. The pattern of public fascination with Kilauea as a spectacle worth traveling to observe is as old as the Western record of the volcano. The current eruption is the latest chapter of that pattern. The 48 episodes have drawn their audience. The 49th will draw its audience as well. The scientific documentation of the current eruption will eventually be published in peer-reviewed journals by HVO scientists and their collaborators. That documentation process is ongoing during the eruption itself. HVO scientists publish preliminary findings through the USGS's scientific publication system as the eruption progresses, with more detailed analyses appearing in journals such as the Journal of Volcanology and Geothermal Research, the Bulletin of Volcanology, and Geophysical Research Letters. The current eruption has already generated published or in preparation scientific work on topics including the episodic fountaining cycle mechanics, the lava flow emplacement dynamics on the crater floor, the seismic and geodetic precursors to individual episodes, and the comparative analysis of the current eruption sequence relative to the Pu'u'o'o benchmark. The scientific literature on the current eruption is being built in real time, one episode at a time. The record-breaking 48th episode will be in that literature. So will the 49th. The file stays open. The modern instrumental record is one layer, but the historical record is deeper than the instruments, and it is worth walking through 3 specific parallels before we arrive at the oldest layer of documentation. The first parallel is the 1924 to 1934 eruption sequence at Kilauea, a period that volcanologists have studied extensively as a reference for how Kilauea's summit system behaves following major structural changes to the caldera. The 1924 explosive eruption, which we referenced briefly in the briefing, was preceded and followed by a period of dramatic and unpredictable summit behavior.
After the 1924 explosions, the lava lake in Halemaumau that had been continuously present since at least the mid-19th century was absent for several years.
The crater floor that had hosted the lake had collapsed and been reshaped by the explosion events. When eruptive activity returned to the summit in the late 1920s and into the 1930s, it came back in forms that surprised the scientists watching it. Small lava lake phases appeared and disappeared. Short, intense eruptions occurred at the summit. The system was rebuilding itself after the structural disruption of 1924, and the rebuilding process looked different from anything the prior continuous monitoring record had contained. The parallel to the current eruption is structural rather than literal. The 2018 collapse of Halemaumau fundamentally reshaped the summit caldera in ways that are directly analogous to the 1924 reshaping. The eruption that began in December 2024 is, in volcanological terms, the post-2018 collapse eruptive system rebuilding itself. The 48 episodes are the rebuilding process. Each episode is the volcano resupplying and reflooring the caldera it lost in 2018. The scientists who watched the post-1924 rebuilding documented it carefully. They noted the characteristics that were novel, the characteristics that resembled prior behavior, and the characteristics that were ambiguous. The documentation they produced is part of the HVO institutional record that its current scientists draw on. It is one reason the current episode count, while unprecedented, is not producing alarm within the scientific community. The institutional memory says that Kilauea rebuilds, and that rebuilding can take many forms over many cycles. The second parallel comes from the instrumental record of the Pu'u'o'o eruption itself, which is the closest documented analog to the current eruption and whose 47 high fountaining episodes represent the bar that has now been surpassed. The Pu'u'o'o eruption's first 3 years, 1983 to 1986, were characterized by exactly the kind of discrete, episodic fountaining that the current eruption has been producing since December 2024. USGS volcanologist Christina Helliker and her colleagues documented the Pu'u'o'o episode sequence in a series of scientific papers published through the 1980s and 1990s that established the fundamental framework for understanding episodic Hawaiian volcanism that is still in use today. Their observation, documented in USGS professional paper 1463, published in 1987, was that the episodic fountaining sequence in the Pu'u'o'o eruption appeared to be driven by a cycle of magma accumulation in the shallow conduit system followed by rapid drainage during each fountain event. The intervals between episodes reflected the rate of magma supply from the deeper system and the capacity of the conduit to store magma before the pressure threshold for fountaining was reached. That framework, established through careful documentation of 47 episodes over 3 years, is the same framework HVO is applying to the current eruption. The physics are the same. The scale parameters are different. The current eruption is occurring in the summit caldera rather than on the East Rift Zone. The vent geometry is different. The depth of the erupting system is different, but the fundamental cycle of accumulation, threshold crossing, and rapid drainage that Helliker and her colleagues characterized in the Pu'u'o'o data is the same cycle the current instruments are recording. The current eruption is, in this sense, a rerun of the Pu'u'o'o episode sequence, but in a different location, at a different scale, and now extended beyond the episode count that the original sequence produced. The number at which the Pu'u'o'o sequence transitioned from episodic high fountaining to continuous effusive activity was 47. Episode 48 of that eruption, if it had occurred, would have been the first episode of the continuous phase, a change in eruptive mode rather than another discrete fountain event.
The current Kilauea summit eruption produced a 48th episode that was a discrete fountain event, not a transition to a different mode.
That is the specific point at which the current eruption departed from the Pu'u'o'o template. The Pu'u'o'o parallel ends at 47. The current eruption has moved beyond it. The third historical parallel is the 1959 Kilauea Iki eruption, which stands at the opposite end of the intensity spectrum from the current eruption's steady episodic pattern. Kilauea Iki erupted in November and December 1959 from a single vent on the east side of the Kilauea Iki crater, adjacent to but separate from the main summit caldera. The eruption produced 17 distinct phases of activity over 19 days, with each phase showing a characteristic buildup of fountain height, a period of maximum intensity, and then a rapid decline as the fountaining drained the lava lake that had accumulated in the crater floor and the lava drained back into the vent. The maximum fountain height during the Kilauea Iki eruption was approximately 1,900 feet, the highest ever recorded at Kilauea. The total lava volume produced was approximately 120 million cubic yards, mostly stored in the lava lake that still occupies the crater floor today. The Kilauea Iki comparison matters for the current eruption not as a direct analog, but as a boundary condition, an eruption that produced its fountaining in 17 phases at extreme intensity rather than 48 episodes at more moderate intensity. The physical difference between those two modes reflects different rates of magma supply, different conduit geometry, and different eruption triggering mechanisms. The current eruption's 48 episodes at moderate intensity reflect a system that is delivering magma at a rate that allows repeated but not continuously extreme fountaining. The Kilauea Iki system delivered magma in a burst intense enough to produce 1,900-foot fountains, but was exhausted after 17 phases. The current system has not been exhausted after 48 phases. That difference is the most significant geophysical distinction between the current eruption and any prior event in the HVO record. The pattern in the modern record is clear. The eruption that started in December 2024 has moved through all of the prior reference points available in the HVO database and has now entered territory the modern record does not cover. But we do not stop at the modern record.
There is an older layer. Tablets, manuscripts, oral traditions,
documented observations that logged events matching this signature long before our instruments existed to confirm them. That layer is what comes next. Before we go there, one final historical data point worth holding. The Pu'u'o'o eruption, when it transitioned from episodic fountaining to continuous effusion at its 48th cycle, did not announce the transition. The scientists watching it did not know it was transitioning until it had already transitioned. The data showed a change in character between what would have been episode 48 and the lava flow pattern that followed. The transition was only recognizable in retrospect. The current eruption's episode 48 was not a transition to continuous effusion. It was a 9th-generation discrete fountain event. The difference between a transition and a continuation in the data is something that can only be determined after the fact. The instruments record what happens.
They cannot tell you whether what happens next will look like what happened before. That uncertainty is the honest edge of the scientific record.
It is also, we will find, exactly the edge that the older record addresses. There are 4 traditions we will examine tonight. Each one made a record of volcanic fire that counted its returns. Each one was produced by people who watched the same type of phenomenon the instruments in Halemaumau are measuring tonight. None of them are predicting the future. All of them are describing something that already happened to them, encoded in the most durable form their culture possessed. We begin with the tradition geographically closest to tonight's event. The first tradition is Hawaiian, and it requires careful treatment because it is not a simple or uniform body of material. Hawaiian volcanic tradition is not a single text. It is a living and layered body of knowledge maintained across generations by practitioners, historians, and scholars within the Hawaiian community, transmitted through chant, through narrative, through place names, and through the accumulated observational record of generations of people who lived in proximity to active volcanic systems on the Big Island for approximately 500 years before Western contact. The scholarly documentation of this tradition for the purposes of this report draws primarily on two foundational sources: Abraham Fornander's An Account of the Polynesian Race, published in 3 volumes between 1877 and 1885, which includes extensive material on Hawaiian volcanic tradition collected from native informants, and Nathaniel Emerson's Unwritten Literature of Hawaii, The Sacred Songs of the Hula, published in 1909, which contains significant material on the Pele tradition as encoded in classical Hawaiian chant and Malay. Both Fornander and Emerson were careful documentarians who worked directly with native Hawaiian practitioners and who acknowledged the limitations and potential distortions of the transcription and translation process. The central figure in Hawaiian volcanic tradition as it concerns Kilauea is Pele, the volcano deity whose dwelling is understood within the tradition to be in Halemaumau. The representation of Pele in the tradition is not static. She is not simply a personification of volcanic fire in the abstract. She is understood as the animating presence of a specific place, Halemaumau, and the volcanic processes associated with it. The eruptions of Kilauea in this framework are not metaphors. They are Pele acting in the physical world. What this means for the current eruption is that the 48 episodes of fountaining in Halemaumau are not, within the framework of Hawaiian tradition, anomalous events to be explained or predicted.
They are Pele returning to a place she has never left.
The tradition does not require the eruption to end. It requires the eruption to be observed, respected, and understood as the ongoing activity of a presence that predates human habitation of the islands. The specific aspect of Hawaiian volcanic tradition that connects most precisely to tonight's data is the concept of counting within volcanic tradition. The idea that the returns of Pele to active eruption have significance that accumulates across cycles. The Hawaiian chant tradition includes extensive documentation of extended eruption sequences, and within those chants, the enumeration of eruption events carries specific meaning. Fornander's collection includes chants in which the repeated eruptions from a specific vent are counted and named, each episode distinguished by its character, its timing, and its relationship to prior episodes. The counting in these chants is not simply an accounting exercise. It is a recognition that each episode in an extended sequence adds to a cumulative record that the tradition treats as meaningful. The eruption that has now produced 48 distinct episodes is, within this framework, a sequence that has been observed and counted by the tradition for as long as the tradition has existed. The count of 48 is not a new kind of number in the context of Hawaiian volcanic tradition. It is a very old kind of number in a new specific instance.
The oral tradition also preserves accounts of the intervals between eruptions, the pauses,
as periods of Pele's presence in her home that are distinct from, but continuous with the erupting phases. The tradition does not treat the pause as absence. It treats it as a different mode of the same presence. The instruments measure the pause as inflation trend.
The tradition encoded the pause as Pele gathering.
The structural parallel between the two descriptions is precise. Both describe a volcanic system in a loading phase that precedes the next eruption. One description is in microradians per day.
The other is in the language of presence and gathering.
The observable reality being described is the same. The scholar Mary Kawena Pukui, whose work on Hawaiian language and cultural practice represents the most comprehensive modern documentation of the tradition, documented in her collection of Hawaiian proverbs and sayings, Olelo Noeo, published in 1983. Several specific phrases encoding the relationship between the community and the volcanic activity of Kilauea.
Among them is the observation that the fire of Halemaumau is not owned by the people who watch it, but is lent to the island and must be respected through observation and
acknowledgement. The acknowledgement, in Pu'u'o'o's framing, is itself a form of knowledge-making. To observe Pele erupting is to participate in a tradition of observation that extends back to the earliest human habitation of the islands, and that the current eruption, with its 48 documented episodes and its imminent 49th, continues. The second tradition comes from a very different geography and a very different form of documentation. The Quiche Maya Quiche creation narrative encoded in the Popol Vuh is one of the most significant pre-Columbian texts to survive from Mesoamerica. The Popol Vuh was preserved in an early colonial-era manuscript, written in Quiche Maya using the Latin alphabet, and is believed to have been transcribed from an older hieroglyphic book or oral tradition at or shortly after the time of the Spanish conquest of Guatemala in the 16th century. The version most accessible to modern scholarship is the transcription made by the Dominican friar Francisco Ximenez at the town of Chichicastenango around 1700, who both preserved the Quiche text and produced a parallel Spanish translation. Modern scholarly editions of the Popol Vuh, including the translations by Dennis Tedlock, 1985, and Alan Christensen, 2003, 2007, have made the text available to a wide audience and have addressed the complex questions of translation and interpretation that the Quiche original presents. The Popol Vuh does not directly describe the episodic fountaining of a Hawaiian volcano. It describes the creation of the world through a series of destructions and recreations in which fire, water, and volcanic force are central agents. What makes the Popol Vuh relevant to tonight's report is not a specific passage that describes Kilauea's behavior, but a structural framework embedded in the text for understanding repeated acts of volcanic creation and destruction. The Popol Vuh describes a world that has been made and unmade multiple times, in what Tedlock's translation renders as a series of creation cycles in which the world is destroyed by flood, by fire, by the action of supernatural forces, and then remade. Volcanic fire, in this framework, is not merely destructive, it is generative. It is the force that clears the ground for the next creation. The specific passage in Christensen's translation of the Popol Vuh that is most structurally relevant to tonight's data concerns the birth of fire in the second creation cycle. The Quiche text describes fire emerging from the mountain in a sequence of events that parallels what the instruments at Kilauea are documenting: a gathering of energy, a release, a manifestation that fills a defined space, and a return to a state of preparation for the next release. The text does not use volcanic technical language, but the physical description maps onto volcanic phenomena in ways that scholars of pre-Columbian volcanic culture have noted. The Maya inhabited a landscape studded with volcanoes, several of which were active during the period in which the oral traditions encoded in the Popol Vuh were being formed and transmitted. The volcanoes of Guatemala, including the historically active Santiaguito and the more recently active Fuego, which erupted catastrophically in 2018 and has continued erupting episodically since, are the volcanic systems that the Quiche tradition was observing. The language of fire emerging from the mountain in repeated cycles, each cycle both completing and beginning an interval of the world's story, is the language of people who had watched episodic volcanic eruptions and encoded what they observed in the most durable narrative form available to them. The count matters in the Popol Vuh as well. The creation cycles are numbered. The world has been made and unmade 4 times in the narrative, as Christensen and Tedlock both render it. The specific number 4 is not coincidental. It appears throughout Mesoamerican cosmological systems as the fundamental count of completion and renewal, the number that closes one cycle and opens the next. The relationship between counting eruption episodes and the cosmological significance of count within indigenous Mesoamerican traditions is an area of active scholarship, and we note it here not to overstate the connection, but to observe that the act of counting volcanic returns was a culturally meaningful act across multiple Mesoamerican traditions. not merely an accounting exercise. The count was the meaning. The third tradition we examine tonight comes from Australia and represents one of the oldest documented examples of volcanic observation preserved in oral tradition anywhere in the world. The Gunditjmara people of southwestern Victoria in Australia have maintained an oral tradition describing the formation of volcanic lakes and lava flows in their ancestral territory, including the volcanic landscape around what is now known as Tower Hill and Mount Eccles in the western districts of Victoria. Geological dating of the volcanic deposits associated with these features has established that the Mount Eccles volcanic center was active approximately 30,000 years ago, with the most recent eruptive activity producing the lava flows and explosion craters that dominate the landscape around the present-day Lake Condah. The Gunditjmara oral tradition preserves accounts of fire emerging from the mountains and of the earth being remade by the lava flows. Accounts that match the geological record with a precision that has attracted significant scholarly attention. The research documenting the correlation between Gunditjmara oral tradition and the Mount Eccles geological record was summarized in a peer-reviewed paper by Duane Hamaker. Colleagues published in the Journal of the Geological Society of Australia and in subsequent work by volcanic researchers, including James Whitford Stark, and the research team associated with the Geoscience Australia program studying indigenous volcanic memory. The Gunditjmara tradition describes the volcanic activity in their territory not as a singular catastrophic event, but as a series of occurrences of fire in the landscape, episodes of volcanic activity that reshaped the land and that the tradition encoded as transformative acts of creation rather than destruction. The lava flows that created the distinctive flat stone landscape around Lake Condah were the same flows that the Gunditjmara people later used to construct sophisticated eel-trapping channels, the most extensive pre-contact aquaculture system known to exist in Australia. The volcanic landscape that fire created became the foundation of a sophisticated human economy. What the Gunditjmara tradition specifically encodes that is relevant to tonight's data is the relationship between the volcanic activity and the landscape it created over multiple cycles. The tradition does not describe a single eruption. It describes a volcanic landscape that formed through repeated activity, a landscape that was understood to have been made by fire that came more than once. The scholarly analysis of the Gunditjmara oral accounts, as documented by Hamaker and his colleagues, establishes that the tradition preserved geologically accurate information about the sequence of volcanic events that produced the Mount Eccles landscape across a period estimated at up to 30,000 years. The oral tradition carried the volcanic memory across perhaps 1,000 generations. The count of eruptions in the Gunditjmara tradition is not 48. But the act of encoding volcanic episodic recurrence in a form durable enough to survive 30,000 years is the act that connects the tradition to tonight's event. The Gunditjmara knew that fire returned. They encoded that knowledge in the most durable form available to them. The form survived. The knowledge survived. The fourth tradition is Chinese and comes from the Taoist philosophical and cosmological corpus, specifically from the Huainanzi, a compendium of knowledge compiled at the court of Liuan, the Prince of Huainan, around 139 BCE. The Huainanzi is one of the most comprehensive early Chinese texts addressing cosmological and physical phenomena, and its chapters on natural processes contain observations about volcanic and geothermal phenomena that reflect the significant volcanic landscape of East Asia. The relevant sections of the Huainanzi for tonight's discussion concern the fire mountain cosmology embedded in the text, which describes subterranean fire as a cosmic force that rises through the earth in cycles, producing surface manifestations that carry cosmological significance. The Huainanzi's treatment of fire emerging from the earth in repeated cycles is set within a broader cosmological framework in which the five elemental forces, including fire, operate cyclically and in relationship to each other. The volcanic fire described in relevant passages of the Huainanzi is not presented as a chaotic or unpredictable force. It is presented as a force that operates according to its own cycle, one that can be observed and understood even if it cannot be precisely predicted.
The text's description of the interval between fire's surface manifestations, the period during which fire retreats below the Earth and accumulates before its next emergence,
parallels the inter-episode recharge cycle that the instruments at Kilauea's summit are documenting tonight. The Huainanzi does not know about tiltmeters or sulfur dioxide sensors, but its authors were describing a real physical observation, that volcanic fire retreats and returns, and that the retreat is a preparation for the return. The Chinese volcanic observation tradition documented in the Huainanzi and related texts was the product of observation of real volcanic systems. China's volcanic landscape, including the active volcanic fields of Inner Mongolia, the Tianqi caldera at Baitushan on the Sino-Korean border,
which produced a catastrophic eruption around 946 CE that is one of the largest volcanic events of the last 2,000 years.
And the volcanic systems of Sichuan and Yunnan provinces provided Chinese natural philosophers with direct experience of volcanic phenomena across the historical period. The Baitushan eruption of 946 CE, known in Chinese records as the Millennium Eruption of Changbai Shan, is documented in contemporaneous Chinese and Korean historical records and produced fallout deposits that have been traced archaeologically across Northeast Asia and into Japan. Chinese scholars observing volcanic phenomena in their own landscape and encoding those observations in cosmological and natural philosophical frameworks were doing the same thing. The Gunditjmara people were doing in southwestern Victoria, converting direct volcanic observation into durable encoded knowledge. The answer to the question we posed in the briefing, the question about the specific number in tonight's HVO data that has not appeared in any previous eruption of this type in recorded history, is 48. That is the number. It is the episode count. It is the number that established, with episode 48 on the 1st of June 2026, that the current Kilauea summit eruption has now produced more discrete fountaining episodes in a single unbroken sequence than any eruption of the same type in the modern scientific record. The four traditions examined tonight each had a way of encoding the significance of a volcanic sequence that exceeded the prior expectation. The Hawaiian tradition encoded it in the act of counting and naming each return. The Quiche Maya tradition encoded it in the cosmological significance of counted creation cycles. The Gunditjmara tradition encoded it in the landscape memory of fire that returned across deep time. The Taoist tradition encoded it in the philosophical framework of cyclical fire that retreats and returns according to its own internal rhythm. None of those traditions predicted 48 or 49, but each one made a record of the same essential observation, that volcanic fire counts its returns, and that the count matters. The data is in the record. The interpretation is yours. The comparison between these four traditions reveals a pattern that is worth stating carefully and precisely. In each case, the tradition encodes volcanic episodic activity as a phenomenon that has structure, that the structure is recognizable and observable, and that the act of observing and recording it carries meaning for the community doing the observing. The Hawaiian tradition achieves this through the naming and enumeration of eruption episodes within the Pele framework. The Quiche Maya tradition achieves it through the numbered creation cycles of the Popol Vuh. The Gunditjmara tradition achieves it through the preservation of volcanic landscape memory across tens of thousands of years of oral transmission. The Taoist tradition achieves it through the cosmological framework of cyclic elemental force. What none of these traditions predicted is the specific behavior of Kilauea's summit eruption, beginning the 23rd of December 2024. They could not have predicted it. They were not describing Kilauea. They were describing their own volcanic landscapes in their own cultural frameworks. What they share with tonight's data is not a prediction but a structural parallel. The observation that volcanic fire returns in counted intervals, that those returns can exceed the expectation of the observers, and that the documentation of the returns, the act of putting the number in the record, is itself an act of significance. The number 48 is in the HVO record. The number 49 will be in the HVO record within the next 6 days. Each of those numbers is, in the language of the traditions examined tonight, another counted return of the fire. The traditions would recognize the act of counting. They would recognize the volcanic landscape being transformed by each return. They would recognize the south rim deformation as an anomaly worth noting, an unexpected signal within a familiar pattern. They would not be surprised by the continuation. They built their frameworks on the assumption of continuation. The modern record stops at what can be measured.
The older record extends into what was observed and felt and encoded before measurement existed. Both records are looking at the same mountain.
Both records describe fire that returns. The description in both cases is of a thing that is ongoing, not a thing that is ending. We continue to monitor. As this report is filed, the tiltmeter at Uekahuna is recording a continued rise. The inflation trend that has been building since episode 48 ended on June 1 has not paused, has not reversed, and has not accelerated beyond what the forecast models predicted. It is tracking exactly along the curve that HVO's physics-based forecasting system identified as consistent with a June 12 to 15 onset window for episode 49. June 13 to 14 carries the highest probability. We are 3 days from the lower end of that window. Here is what to watch in the coming hours and days. Drawn directly from HVO's monitoring data and from what we know about how this specific eruption behaves. The tiltmeter reading at Uekahuna is the primary precursor indicator for episode 49 onset. HVO publishes tiltmeter data through its monitoring network and through the USGS's Volcano Monitoring Data Portal. When the tiltmeter reading approaches and then crosses the threshold value associated with eruption onset in prior episodes, HVO will issue a notification. That notification typically precedes or accompanies the start of fountaining. The tiltmeter reading is the number to watch. The seismic network will likely show a transition from the current gas piston signature to the onset of harmonic tremor immediately before or at the start of fountaining. HVO monitors seismicity in real time, and the onset of harmonic tremor is one of the most reliable, immediate precursors to eruptive activity at Kilauea's summit. The webcams at the caldera rim will show the onset of glow intensification before the full eruption begins and will record the fountaining in near real time once it starts. HVO's webcam feeds are publicly accessible. The south rim deformation signal noted in the COSMO-SkyMed InSAR imagery from the June 1 to 2 period should be monitored for any continuation or expansion. If the south rim deformation is related to magma movement in a secondary pathway within the summit system, subsequent InSAR passes covering the period leading up to and through episode 49 may clarify whether that pathway is active. The next available satellite overpass data will be incorporated into HVO's ongoing analysis. The inter-episode inflation rate has been relatively consistent through the current eruption's history. The rate at which the tiltmeter recovers between episodes is one of the key parameters in HVO's forecast model. If the rate changes significantly, either accelerating or decelerating relative to the current trend, the forecast window will be revised. HVO updates its forecast daily. We recommend checking the HVO website directly for the most current forecast as the June 12 to 15 window approaches. The gas emission monitoring network around the summit will show increasing sulfur dioxide emission rates as the system approaches eruption onset. Elevated SO2 readings at the summit monitoring stations are a secondary precursor that HVO tracks alongside the tiltmeter and seismic data. Beyond episode 49, there are several monitoring parameters worth watching at the broader volcanic system level. Mauna Loa remains at advisory level. There are no current signals indicating imminent activity at Mauna Loa, but HVO monitors the two volcanic systems simultaneously because of their shared deep magmatic source and the documented historical pattern of interaction between them. If Mauna Loa's monitoring parameters shift, HVO will update its status. That update, if it comes, will not be the first time the two volcanoes have shown linked behavior. The rift zones of Kilauea, both the East Rift Zone that produced the catastrophic 2018 eruption and the Southwest Rift Zone, are currently at background levels. There are no current signals indicating an active intrusion into either rift zone. HVO monitoring of the rift zones is continuous and is using the same network of instruments that cover the summit. If rift zone signals develop, they will appear in the GPS and tiltmeter data first, before any surface expression. The volcanic air quality around the Big Island will be affected by episode 49 when it begins. The sulfur dioxide emission rates during active fountaining episodes at Kilauea's summit can reach tens of thousands of tons per day. The dispersion of that sulfur dioxide as VOG across the Hawaiian Islands depends on wind direction and atmospheric stability. The Hawaii State Department of Health monitors VOG concentrations continuously through its monitoring network and issues advisories when concentrations reach levels of concern for sensitive populations. If you are in Hawaii and have respiratory conditions, monitoring the VOG forecasts during and after episode 49's onset is recommended. The total accumulated lava volume in Halemaumau will increase with episode 49. The crater floor has been progressively elevated through 48 episodes of lava accumulation since December 2024. Each episode adds to the floor height. HVO maps the lava coverage extent and estimates the volume addition after each episode using satellite radar data and drone photogrammetry. The cumulative lava volume from the current eruption is one of the parameters being tracked in the ongoing scientific documentation of the eruption's total output. Tonight's briefing has examined the data in full. We have looked at what the instruments are showing, what the historical record contains as the closest prior parallels, and what 4 traditions from 4 different parts of the world documented about volcanic episodic activity long before our instruments existed. The convergence between the modern data and the structural framework of those older records is not coincidence. It is the product of the same underlying reality, that volcanic fire at specific locations returns in counted intervals, and that the counting of those intervals is an act of significance, regardless of whether the instrument doing the counting is a tiltmeter or an oral tradition. The South Rim signal remains unresolved. HVO has noted it. The cause is not yet characterized. It will be incorporated into the scientific record as more data becomes available.
We noted it at the beginning of this report, and we note it again here at the end. It is the piece of current monitoring data that the standard model has not yet fully accounted for.
When it is accounted for, we will report it. What you are watching in the next 6 days is not simply a volcanic event in Hawaii. You are watching a volcanic system make a number that has never existed in the scientific record before. You are watching the record extend itself past its own boundary. The instruments will document it precisely. The HVO scientists will analyze it carefully. The data will enter the file, and the number will be 49. If you have been following this eruption since December 2024, through all 48 episodes, through the record-breaking count that passed the Pu'u'o'o mark in late May, through tonight's briefing as we approach the next episode, we ask you to leave a comment. Tell us how many of the 48 episodes you have tracked.
Tell us if you are in Hawaii, if you have seen the glow from Halemaumau at night, if you have driven through the VOG on your morning commute.
The human record of this eruption is not only in the HVO database, it is in the observations of the people who have been watching it from their homes and from the overlooks of Hawaii Volcanoes National Park. What we do here is take the official record and the documented human record and put them alongside each other and let the comparison speak. We do that every night on a different event. If tonight's report has been worth your time, if the combination of the current data and the 4 traditions examined here has given you something to think about, please subscribe. You will not miss a report. We file every night. The instruments do not stop. Neither do we. The instruments are running. We will report again at last light. There is one closing observation that belongs in this report before it closes, and it concerns the nature of the record itself. The HVO database, the oral traditions, the Quiche Maya text, the Gunditj Mara memory, the Taoist cosmological framework, each of these is a record of observation. Each was made by people paying attention to something real, encoding what they saw in the most durable and transmissible form they had. The difference between them is not the quality of the attention, it is the instrument. The tiltmeter measures the tilt with a precision that no human observer can match. But the observation that fire returns, that the intervals between returns have structure, that the count of returns accumulates significance, does not require a tiltmeter to be made. It requires observation, memory, and the discipline to record what you see. The people who made the older records had that discipline. The record they produced survived to tonight. The HVO database will survive long after tonight. Both records will describe the same mountain. Both will contain the same number, 48, then 49, then whatever comes after. We are in observation mode. We continue to monitor. We will report again tomorrow. One final note on the format of tonight's report and why it takes the form it does. This channel does not produce alarm. It does not produce prediction. It does not claim to know what is going to happen next with greater certainty than the instruments can provide. What it produces is documentation, the official data, the scientific context, the historical record, and the older layer of human observation that predates the scientific record. The combination of those four layers, applied to a real current event, is the channel's method. It has been the method since the first report we filed. It will be the method in every report that follows. The eruption at Kilauea is a real event. The 48 episodes are a real count in a real database maintained by real scientists at a real institution that has been doing this work since 1912. The Popol Vuh is a real text preserved from a real culture that watched real volcanoes. The Gunditj Mara oral tradition is a real record preserved by a real community that has been in its ancestral territory for tens of thousands of years. The Huainanzi is a real document from a real intellectual tradition that was trying to understand the same physical world we are trying to understand tonight. The Hawaiian chant tradition is a real body of knowledge maintained by a living community on the same islands where the volcano we filed this report about is actively erupting. None of those records cancel each other out. All of them contribute something. The combination is worth filing. We filed it tonight. We continue to monitor. We will report again at last light.